all the products became our benchmark.
Groundbreaking new product.
A completely new approach.
Numerous questions immediately arose.
30% increase in efficiency.
Revolutionized from a fluid mechanical perspective.
It is the year 2008. The Invent engineers realized that all horizontal flow accelerators, a product which has been established in the market for decades, had outlived their effectiveness and could be vastly improved in terms of efficiency. This is the story behind it. During the development and launch of the hyperboloid mixers in the 90s, the Invent engineers frequently came into contact with horizontal flow generators.
Through our work with hyperboloid mixers, we were able to demonstrate that horizontal mixers are not well suited for rectangular or square tanks, but they are effective in so-called recirculation basins. However, when we examined existing products, numerous questions immediately arose.
In the past, the focus of the developers was solely on propeller design, overlooking numerous crucial factors. Above all, there was a failure to acknowledge that a mixer must always be perceived as a flow machine in a reactor.
We then proceeded to acquire all the products available on the market and subjected them to various tests in our water channel. The product that outperformed all others in our comparison became our benchmark.
Our aspiration was to attain a substantial increase in efficiency in the double-digit range.
Or rather, surpassing the market's lead performer by over 10%. From a technical perspective, these are worlds apart, which required a completely new approach.
The first step to success was reversing the flow direction. Simply observe a propeller aircraft. By reversing the flow direction, the propeller operates without interference, enabling a smooth and unobstructed flow. Efficiency increase, 10%.
The desired horizontal flow is generated solely by the axial velocities produced by a propeller. The energy of arising radial and tangential velocities remains unutilized, leading to a loss in energy. The anti-vortex fin and the fluid mechanically optimized design of all components significantly diminish these vortex losses. Additional 10%.
If the term horizontal flow accelerator is interpreted too literally, aligning the jet axis perfectly horizontally will lead to high-velocity impacts with the ground, resulting in unnecessary energy dissipation. However, by angling the jet axis slightly upwards at a precisely calculated angle, these losses can be avoided. Bang, another 10%.
Whilst there were ongoing discussions regarding optimal propeller geometry and number of blades elsewhere, we introduced a groundbreaking new product to the market with a 30% increase in efficiency.
Additional features, including an optimized propeller design, component coordination, and aligning the rotational speed with the air volume, further solidify this efficiency gain.
High-quality CFD simulations are initially validated and capable of capturing even the finest details of complex flows. It is through this approach that a product can be truly understood and revolutionized from a fluid mechanical perspective.
The design and selection of materials ensure the CYBERFLOW accelerator requires minimal maintenance and offers outstanding robustness and durability. It is suitable for all types and variations of recirculation basins. Depending on the facility type and requirements, the product size, number of blades, and propeller shape can be tailored to meet customer requirements. Over the last 12 years, the CYBERFLOW accelerator has proven its reliability and is utilized worldwide. And for maintenance purposes, for example, the CYBERFLOW accelerator can easily be released from the base frame and lifted out of the tank along a guide rail. Subsequently, the propeller and powertrain unit is lowered along the guide rail back into the filled basin, towards the base frame, and then securely locked in place. Lower, touchdown, lock.
Among Invent's portfolio, no other product encompasses our design approach and engineering philosophy as distinctively as the CYBERFLOW accelerator. Instead of delving into the details of propeller geometries, We have forged an entirely new conceptual framework, delivering a simply better flow machine to the market.